Okay, today we are going to see the example that you see on the screen. It's an electrical system and it has two loops. Therefore, we will have two second-order differential equations, and our objective right now is to find out the state space form for the system. So the first thing we're going to do is to derive the, let's see, let's gotta do this in here. That's the system itself. Let's see how we're doing if we go up here. And okay, let's do the best we can in here. So we have this two equations that we need to derive. So you could say, why don't we say loop 1, and then we are going to say in the loop 1, you said that the summation of the voltages on a loop should be equal to 0. That's what Kirchhoff's law says. So it's the same thing as writing that the voltage over C1, which is 1 over C sub 1, the integral of I1 dt, plus the voltage, which would be R sub 1 times I1 minus I sub 2, yeah? And then the other voltage, which would be plus L1 times di1 dt, this would be equal to the voltage V. So that's in the first loop. On the second loop, we need to write down, you would say, okay, loop 2, and in here we also gonna have to say consistently that the summation of the voltages on loop 2 should be 0. That means that we will write down, this would be I sub 2 times R sub 2 plus 1 over C sub 2, the integral of I sub 2 dt, plus L sub 2 times d I sub 2 dt, and then you will say plus the, or minus in this case, the voltage, which would be minus R1 times I1 minus I sub 2. And that would be equals to 0. Yeah? So these are the two differential equations that I have. Still, they are not in the form that I would like because the do you see our problem here? While this was easier to derive, this has an integral, this has a derivative here, this other one also has an integral and has a derivative over here. It's not very nice. So what we're going to do is to say that I1 is equal to dq1 dt, which would be the charge, and that I sub 2 is dq2 dt, which is the charge on the other one also. So if this is true, then we can write our equations in a little easier form. That would be 1 over C sub 1. What would be the integral of I1 dt? This would be Q sub 1, yeah? Plus R1 times the d sub I dt 1 minus, no, dq1 dt minus dq sub 2 dt, like that. And then plus L1 times d squared q sub 1 dt squared. This is equals to v, like this. Okay? And then you have the other one, which would be dq sub 2 dt times r sub 2, and then plus 1 over c sub 2, and then the integral of I sub 2 dt, this is would be q sub 2, and then plus L sub 2 times d dq d square q2 dt square, like that, minus r1 times dq1 dt minus dq sub 2 dt equals to 0. Yeah. So you see here, we have still some work to do, because based on what I told you, we need to rearrange these equations to be able to transform them into first order differential equations. So what we're going to do is we'll rearrange those equations and derive the state space form for it. So remember what I told you, leave the term of the highest order derivative on the right hand side, and that would be the first thing we're going to do. So we're going to pause this for a moment and then we'll continue.